At this point, we have produced numbers and images and tried several kinds of lists. But when we consume a list, we can actually produce new lists too. This allows us to filter down lists and remove things we don't want. In this example, we're going to filter for all movies of a given genre in a list of movies. We've already defined a movie struct earlier on, but we'll need a couple more examples. We'll define the movie Harry Potter as a make movie. Say its title is Harry Potter 1. That would be the Sorcerer's Stone. Thank you. 159 minutes long, and it's a fantasy movie. And we'll define our second movie as The Labyrinth. And that's a make movie called The Labyrinth. It's 101 minutes long, and it's also a fantasy movie. Now we need to create a data division for a list of movies. A list of movies is either empty or cons a movie on a list of movies. We'll need some examples of our list of movies. First, we'll have the simplest type, the empty shelf. No movies on our shelf. Then we'll make a list called My Movies, which conses together Harry Potter with The Notebook that we defined previously, with The Avengers, which we defined previously, and Labyrinth, which we just defined right up on top of us. Put in empty and close on all parentheses. And then we'll define one last list called Fantasy Movies. So this conses together Harry Potter with The Labyrinth and empty. So we have our 3 examples of movie lists for our 4 movies. It's time to create our function findMovies. FindMovies is a function that consumes 2 things, a list of movies and a string, producing a new list of movies. So consumes a list of movies, and that second parameter is a genre, which is represented as a string, and produces only the movies in that genre. We get to define the header. That's still fairly straightforward. We use findMovies. We need a list of movies. We also need a genre. Then we have a dot, dot, dot. Now, this is going to be a very complicated function, so it's a good idea to have a lot of unit tests. We've constructed 2 of our examples to be connected, so it's easy to make them. And of course, we have a case where the list is empty. So check, expect, find movies, empty shelf. If we're looking on our empty shelf for any fantasy movies, we expect to find the empty list. If we check, expect, and if we try and find movies on My Movies, the My Movies list, and are looking for fantasy movies, that ends up being the same as our fantasy movie list. So that comes out nicely. And finally, if we try and find movies, or not finally, one more, we'll do find movies on My Movies and look for action. That'll only return one movie, The Avengers, just a list of one thing. Finally, this actual time, finally, we'll find our movies and look through our fantasy movies for any action, and that will turn up empty. So here we have a list that didn't start off empty, but returned the empty list because we couldn't find anything. We've got 4 unit tests. That's going to give us pretty good code coverage. It's time to write the body. We get the template for free, and that is going to help considerably. A list of movies is the thing we're consuming, so we know that we're going to need 2 clauses, one for the empty on a list of movies, we'll return something, and then something for the cons case, dot, dot, dot. We also know that we're going to need to use the first of a list of movies, and we're going to need to call findMovies on a list of movies for the genre. So the rest of the list of movies on the genre. But we're going to need to combine these in some way, the first and the findMovies call. All right. We know that if we have no movies, we're going to return the empty list. We said that if we have an empty shelf, we've returned empty. That part's pretty straightforward. The recursive case is where things get hard. We have a question to ask. Is the first movie in the list the genre that we're looking for? If it is, then we should include it in the list we're going to create. Otherwise, we should not. Since we're doing either one thing or the other, we need either an if or a cond. If you don't remember, an if function consumes a question, such as true or false, anything that returns true or false, And if it's true, returns the first of those of two responses. Otherwise, it returns the second of two responses. So we can use that to sort of branch without having to use a more verbose cond. In this case, we're going to ask if we're going to compare the genre given as a parameter up here with the first of the list of movies. In particular, we're going to ask if the genre of that movie is the same as the parameter genre. So in order to do so, we need an if, and then we need our question. We've got two strings, the genre and the genre of the movie, so we'll use string equal huh, and that's comparing the genre given as a parameter with the movie given in the list. But if you recall, the first of a list of movies is not a string, it's a movie. But movies do have a field called genre. So we can use the movie selector, movie genre, to get out the genre from the movie. So we have right here an expression, movie genre first a list of movies, that will extract out the genre of the first movie. Now, that's our question. We still need to write the first case, where we want to keep the movie around, and the second case, where we don't want to keep the movie around. Since this answer will also be the result of the entire function, we know that this is going to have to create a list of movies somehow. And so will the alternate case. It will also have to be a list of movies, whatever this is going to produce. Well, we don't want to create an empty list, so we're going to have to make it a cons, because a list of movies is either empty or cons. So we know that we're going to have to use cons here somehow, and that consumes two things. We'll combine the first movie with the result of recursively calling the function on the rest of the list. Let's write this out. First, a list of movies, and the find movies on the rest of a list of movies, also passing in the genre. This probably wasn't intuitive to read, but it's an extremely common pattern for making new lists. It's like we took a piece off of our old list, applied an operation to the rest of the list, thereby getting another rest of the list, and then we put that piece back together. We broke off a piece, did something to the rest, and then put them back together. Get used to this idea, because whenever we're filtering, we're going to use this pattern. All right, so that was our first case. For the remaining case, we don't want to keep the movie. And it's similar. We still need to call find movies. But we don't need to combine it back with the current first element, since we're tossing that away. Instead, we're just going to return the result of calling the recursive function. So here we go, find movies, rest of a list of movies, and genre. So it's a lot simpler. And that deletes everything else. Finish off the... There we go. Great. Notice that both times we use genre unmodified. The function is always checking for the same genre each time, even as the movie we're checking changes. This function is extremely complicated. Let's try running it and seeing if we got our check expects to pass. Everything seemed to have worked, with full code coverage too. It's difficult, but it demonstrates a very common pattern of needing to remove things from a list, thereby producing a new list. So you need to make sure you memorize it.